So welcome back guys. We are here. I'm here to give you the summary of the chapter 8, subnetting an IPv4 network. So let's start. So subnetting, we have network segmentation, broadcast domains. Each router interface connects a broadcast domain, and broadcasts are only propagate within its specific broadcast domain. Problem with large broadcast domains. So first we have slow network operation due to the significant amount of broadcast traffic. Slows device operation because a device must accept and process each broadcast packet. So we have the solution: reduce the size of the network to create smaller broadcast domains in process called subnetting. These smaller networks spaces are called the subnets. So a reason for subnetting: network administration can group devices and services into subnets that are dominated by location. Reason for subnetting: and network administrators can group devices and services into subnets that are determined by device type. Then we have the octet boundaries, or we call the octet boundaries. Subnetting network in the octet boundaries. The we have the classless subnetting, which the /25 borrowing 1 bit from the fourth octet creates two subnets supporting 126 hosts each. /26 borrowing 2 bits creates four subnets supporting 62 hosts each. /27 /27 borrowing 3 bits creates 8 subnets supporting 30 each hosts. /28 borrowing 4 bits creates 16 subnets supporting 14 hosts each. We have the /29 borrowing 5 bits creates 35 subnets supporting 6 hosts. And lastly, we have /30 borrowing 6 bits creating subnets supporting 2 hosts each. So we have here subnetting formulas. For example, this is one of the formulas: 2 raised to n minus 2. We have the subnetting the prefix, 100 subnets with a 16 network, creating, calculating the host using the formula given. Then subnetting based on host requirements. Two consideration when planning subnets. First, the number of host addresses required for each network. Second one, the number of individual subnets needed. Then the more bits borrowed to create subnets, the fewer host bits available. Subnet based on organizational structure. Here at the cloud, we have executive management, research and development, technical support, engineers, sales, human resource, and it's all corporate network. So we have the variable length, subnet mask. You should know the variable length. Subnet was further divided to create 8 smaller subnets for host each. VLSM subnetting scheme. This is the way in order for you to practice the uh, creating of addresses. What's what we call the BSLM. So here, example in the BLSM from a running config of a router interface gigabit internet 0/0 IP address 192.168.20, then exit interface serial 0/0/0 address, then exit again interface serial 0/0/1. Now type also the IP address and the MAC address, then end. Addressing schemes. Upon completion of the section, you should be able to implement a BSLM and addressing scheme in order to make your work more efficient and reliable. Network address planning. About your when you are planning, when you want to work and want to make your own network address. The student LAN, faculty LAN, admin plan. And then planning requires decisions on each subnet in terms of size, the number of hosts per subnet, and how host addresses will be assigned. Then primary consideration when planning address allocations, we have the prevent duplication of addresses, provide and control access, monitor security and performance, and planning address allocation. And IP address range, we have the network, host device, servers, printers, intermediary device, gateway router. Then design considerations for the IPv6. The IPv6 global unicast address. The IPv6 global unicast address normally consists of a /48 global routing prefix, a 16-bit subnet ID, and a 64-bit interface ID. Then, and also at the IPv6 subnet allocation, we had the address block located, and then available subnets. You're going to configure and know the IP address. Uh, so the IPv6 multicast addresses assigned IPv6 multicast addresses. So two common IPv6 assigned multicast groups include FF02, one all nodes multicast group, all IPv6 involved device join and same effect. And similar to the all nodes, multicast address matches only the last 24 bits of the IPv6 global unicast address of a device, automatically created when the global unicast or linked local unicast addresses are assigned, created by combining a special FF02/104 prefix with the rightmost 24 bits of its unicast address presentation. Router solicitation and router advertisement message includes 4 new protocols as a part: neighbor discovery protocol, router solicitation message, router advertisement message, neighbor solicitation message, neighbor advertisement message, router solicitation message, and many more. Then we have the subnetwork and host portions. Once implemented, IP network needs to be tested to verify its connectivity and optional performance. Then the HTTP enables the automatic assignment of addressing information such as IP address, subnet mask, default gateway, and another configuration information. So That's all for the chapter 8. Hope you like it and hope you learn. Thank you.